Today's video is about block diagram fundamentals and reduction techniques. Analysis of complicated system is very difficult. So to find transfer function for that system is also complicated. So basically block diagram is used to find out the transfer function in the easier way. So block diagram is a shorthand pictorial representation of system. In this, the system components are also called as elements of the system. For block diagram, we should know the basic components of the block diagram, that is signals, system or block, summing junction, summing junction or summing point, then pick off or take off point. Here we can say these are the signal. R of S is reference signal, that is input signal, and C of S is output signal. Then blocks can be represented with the rectangular box. Inside that we write down the gain of that block. So here G of S is the gain of that block, then R of S is the input and C of S is the output. Summing junction or summing point. The summing point represent with the circle. In this we can add or subtract number of inputs. So R1, R2, R3 are inputs for the summing point, and output of summing point is the algebraic sum of the input. Then fourth one is pick off point or take off point. In the take off point, same input signal is given to the different points. Now we'll see one by one in detail. Like the first one is block. The simplest form of the block diagram is a single block with one input and one output. So here we can see X is the input and Y is the output. The arrow represent the direction of information or signal flow. The G is the gain of that block. In this we have used feedback path. So when the flow of arrow is from left to right, that is input to output, then it is known as forward path. And when it is output to the input, that is right to left, is known as feedback path. Next one is summing point. So summing point, the output is algebraic sum of the input. Here there are two inputs and you'll get the one output. Addition and subtraction with the appropriate plus or minus sign is considered for the summing point. If the addition is given, then signal get added. If the minus sign is associated, then signals are subtracted from each other. So here we can see X and Y, both the signs are positive, so at the output we will get the addition X plus Y. In the second figure, the X is positive and Y is negative, so at the output we will get the subtraction, that is X minus Y. Any number of inputs may enter into summing point and will get the single output. So in this, n number of inputs can be considered into addition. The next component is takeoff point. So here we can see the X signal is distributed at the various points. The output signal can be applied to two or more points from a takeoff point. The same signal is applied at the various points. This permits the signal to proceed unaltered along several different paths to several destinations. Now we'll start with the reduction techniques. For reduction technique, there are some rules. It is used to simplify any complicated system. To bring it into simple form, it is necessary to reduce the block diagram, but using proper logic such that the output of that system and the value of any feedback signal should not get disturbed. Therefore, following rules are used for the block diagram reduction. So, we will start with the rule 1, that is block in cascade or in series. The gain of blocks connected in cascaded get multiplied with each other. So here you can see there are two blocks with the gain of G1 and G2. Therefore at the output we'll get multiplication of both gain. So we can represent this two block into the one block with the G1 and G2 gain. So instead of this 3 or more different series block, we can represent with the one block. But if there is takeoff or summing point in between this block, the blocks cannot be said to be in series. Now we'll see rule number 2. Blocks in parallel. The gain of blocks connected in parallel get added algebraically. In this, G1 and G2 are both different gain. It get added with this two block. So if you see the sign of G1 and G2, the summing point is positive. So we can represent this into one block with the addition of G1 and G2. But in this, both the direction should be same. Next one is eliminate feedback loop. Here G is the forward gain and H is the feedback gain. So here we cannot apply rule number 2, that is block in parallel, because the direction of flow is different, forward and feedback. In this case we can consider this as a feedback loop. So the three components like summing point, then forward gain and feedback gain represent into the one block of feedback. So already we have seen the transfer function of closed loop system is G upon 1 plus minus G into H. Now in this, the sign of plus minus is depend on type of feedback. So if feedback is positive, then in the equation it is 1 minus G into H. If the feedback is negative, then in equation it is G upon 1 plus G into H. Similarly, if H block is missing, then we can consider the gain of that path, that is H is equal to 1, and we can represent the whole system into one block, that is G upon 1 plus minus G. Rule number 4. Swap with the two neighboring summing point. Here there are two summing point A and B. If there is no in between block or summing takeoff point in a summing point, then we can interchange or swap the summing points. Order of summing points can be changed if two or more summing points are in series with no block or takeoff point between it. Change the position of two summing point, then only you will get the same output. Now we'll move to the rule number 5, that is shift summing point before a block. In this we can see the gain is G, and after that the signal is given to the summing point. For the simplification, if you need to move this summing point before block, we can do it with the considering that gain of 1 by G. Both the case give same output. Even we can shift summing point after a block. So in this figure, the summing point is before the block. If you want to move it after the block, then we can move it with the multiplying the gain G. Rule 7. Take off point before a block. Now here G is the gain and this is the takeoff point. So we can move takeoff point before a block by adding one more gain block. Similarly, we can shift takeoff point after a block. For that, we have to add gain of 1 by G. Both the cases giving same output. All the rules are used for the simplification to calculate transfer function. As far as possible, try to shift takeoff point towards right and summing point to the left. For solving this block diagram, we start with the first rule. Like here, we can apply rule number 1, that is block in series, for G1 and G4. So G1 and G4 can be transformed into one block, that is G1 into G4. Again, G3 and G2 are considered in the transformation of 2, that is rule of parallel. So we can represent this 2 block and the summing point into one block with the algebraic sum of G2 and G3. Now block is one more block we can simplify, that is minor loop. Here G1 and G4 is already we have used rule number 1. Now we can eliminate feedback loop. So complete loop is converted into one block with the rule of transfer function of closed loop. So if this is the forward gain G1 into G4 and the feedback gain is H1. The type of feedback is positive, therefore the sign is 1 minus G1 G4 H1. Now this is the simplified form. Again here we can apply rule number 1, that is block in series. So these 2 block get multiplied. Now we can apply rule number 3, that is eliminate feedback loop. So finally we'll get transfer function C divided by R is equal to G1 G4 in the bracket G2 plus G3 divided by 1 minus G1 G4 H1 plus G1 G4 in the bracket G2 plus G3 into H2. One more example. Now if you see the circuit block diagram in a first loop, we cannot apply rule number 1 or 2 or any rule number 3. So for that we directly come to the shifting of takeoff point. So if you shift the takeoff point, that is before G4, and whenever we are shifting takeoff point at the left hand side, that is after the block, we have to divide that gain. So here we have divided the gain H2 divided by G4. Now here we can see G3 and G4 are in series, and after the applying rule number 1, we can consider the eliminate feedback loop. After the rule 3, the G2 becomes series with the next block, and the above H2 divided by G4 block come in the feedback loop. Now G1 come in series, therefore we can multiply this block with the G1 and again it will come into feedback loop, so we can eliminate feedback loop and finally we'll get transfer function, that is output upon input is equal to G1 G2 G3 G4 upon 1 minus G3 G4 H1 plus G2 G3 GH2 plus G1 G2 G3 G4 H3. Now we'll take one more example. Now in this we can see there are three summing points connected back to back. There is no takeoff point or any block in between this. So we can convert this circuit into one summing point. Now all the feedback gain H1, H2 and H3 are connected to the one summing point with their proper sign. Now we can use rule number 2, that is block in parallel. So all the gains are converted into one block. So according to their sign, H1 minus H2 plus H3. Now it is very easy. Now we can consider this is as a feedback loop, so we can eliminate this feedback loop and after that the G1 block comes into series with the feedback loop. So we can find out the transfer function by multiplying G1. So R C of S upon R of S is equal to G3 G2 G1 upon 1 plus G3 H2 the bracket H1 minus H2 plus H3. So this way we can solve different problems.